Hi friends, welcome to GMK tutorials. In this video, we are going to continue our discussion on analog electronic series. So today we are going to discussing about the differential amplifier in small signal model. Okay, so we can also call it the small signal model representation of a differential amplifier. Okay, small signal model. Small signal model of a differential amplifier. Okay. So for that purpose, first of all, we have to represent the general representation of the differential amplifier. Then we can draw the small signal model for this one. So let us see here. So in case of the differential amplifier, we have two types of a transistor. Okay. So this is a basic diagram for the differential amplifier. Here, the transistor Q1 is a transistor. This is a Q2 transistor. So in this case, RC1 and RC2 are identical. Therefore, both are same. Therefore, at the same time, Q1, Q2 transistors act as a identical transistors. Okay. So the small signal model for this one is nothing but, suppose if you are thinking it is a one kind of a, just this is nothing but one part of this one. So this side is part is also similar to the one kind of a structure, right? So that can be represented by using a small signal model. Let us see here, small signal model for that one. So we have a transistor. So generally it can be represented as a R pi. Okay, with this is the input side. Okay, so this can be represented as R pi 1. Okay, for input side representation. At the same time, the output side, the transistor having a dependent source, that is nothing but it is depends on a voltage. So GM1 into VBE1. So this is the output section. At the same time, output side is also having a output resistance that can be represented as like this. Okay, so this is the one side. At the same time, second side also, for second part also, there is a one more. So this is also second part. So in this case also one kind of a, so it is also represents a same structure, similar structure. So for that purpose, we have to represent the with in this direction. So that is nothing but some resistance, output resistance. At the same time, output current follows the some direction like this. Okay. So at the same time, it is also equal to some resistance, input side resistance, that is nothing but R pi. So this is the equivalent model for the transistor for internal. At the same time, it is also having some connections for collector side also. So for that purpose, we have to represent the corresponding connections also. So let it be take here. This is a one resistance. This is also one more resistance. These two are connected. Okay, so it is connected to the virtual ground. So therefore, so this is generally called the virtual ground. So at the same time, it is also having some input. It is also having an input. So for that purpose, I have to represent this is the input voltage. So it is also second input voltage. Okay, therefore, so it is also input. So it can be represented as a V in 1, V1. It is also called as the input V2. At the same time, the current direction in this direction. So this is nothing but R pi into GM into VB1 one side. So this resistance can be treated as R01. That is nothing but output resistance 1. Okay. So this is nothing but RC1. Okay. This is nothing but RC1. So this is also called as RC2. Okay. So this resistance can be represented as R pi 2. So this is nothing but, so this resistance is nothing but R pi 2. Just I will represent below. So this value is nothing but in terms of Gm into VBE2. So this resistance value is equal to output resistance RO2. Output resistance RO2. So this is a small signal model for a differential amplifier. If you are designing a differential amplifier with a transistor, but we have a one more resistance is there, that is nothing but RT resistance. In case if you are treating it as a separate resistance, you can design separately. Suppose if I am taking separate, so this is nothing but a collector terminal, it is nothing but an emitter terminal. So therefore I will connect it to the separately, so like this. So this is nothing but 2RT. At the same time, if you are taking is a collector side, so here also one more resistance, that is nothing but 2RT. This is a complete equivalent model for of a differential amplifier. Okay. So in this case, voltage gain AD is equal to, suppose if you are taking a, so there is a one more representation, we have to represent the output sections also. Output is nothing but, it can be treated as a V0 2, it can be treated as a V01. Okay, so here one important criteria is nothing but there is no restriction for taking a, suppose if you are taking a, this value is equal to negative, it becomes as a positive output. That is the one. Suppose if you are taking a positive value, here you will take the negative value. That is a represent. But I will call this one is equal to V0. So this is a negative voltage. Suppose if you are taking a negative voltage here is the input voltage, then you will take as a positive value. So that's why I can call V01 is equal to positive and V02 can be treated as a negative. Just it is nothing but some assumption, we don't have any restriction for this one. So based on the inputs, it may be varying. Maybe some of the literatures, always it can be treated as a V01. So this part can be treated as a V01 only, always V01 like this. So this can be treated as a V02 opposite. So at that time you will take a negative signal, then you will get a positive one. If you are taking a positive, you will get a negative signal. So the only difference is that polarities may be changed. Suppose if you are taking in this direction, the output value AD is greater than 0. Suppose if you are taking the opposite version, you will get AD values is negative. That is the only basic difference. Suppose as per our assumption, with I will take blue color representation point of view, AD value is equal to positive. Suppose if you are taking the another representation, that means first one is nothing but V01, then you will get AD is equal to negative. That is the only difference. Okay. I hope it is very clear, guys. Okay. So this is a small signal representation. Just you have to remember for this one. Okay. So if you have just you will go through the small signal representation of a transistor, then it is very easy to understand why we are representing R pi. So GM into V, how we are getting GM into VV. So why it is a dependent source. If you want to learn more information, please go through the small signal model of a transistor or diode. You will get a better clarity about the small signal equivalent representation of a differential amplifier. So I hope it is very clear, guys. Okay. So just I will do the everything for a examination point of view. That's why I will take. I don't want to take much more time regarding this one. Okay. So thank you, guys. Thank you for supporting.